Hello, I'm Bhaskar Ravishankar from the University of Minnesota, the presenting author of this study. Autonomous contractions of the bladder detrusor smooth muscle have been observed and reported across numerous studies and model systems. These signals have been linked to pressure regulation during bladder storage or filling, and even extended to disorder concepts like OAB, retention, and so on. Several studies have attempted to quantify these NVC signals, but have not been scalable to routine clinical application. So the goal of this study is to quantify NVC signals from retrospective clinical urodynamics data using a scalable workflow that we have developed. Our workflow utilizes fast Fourier transform technique to analyze NVC signals to provide a quantitative measure of bladder state. We hypothesize that changes in NVC signals which occur as a result of bladder filling can be captured as spectral power and weighted average frequency components using our workflow. We have used 12 patient data sets for this study. We start by capturing urodynamics data in a CSV format for easier processing. We divide pre-void pressure data into 300-second bins or segments and analyze each segment by first applying FFT on both pressure signals, then subtracting the abdominal components from the vesicle signal to reveal a bladder specific power plot within the 1 to 10 cycles per minute range, from which we calculate spectral power and weighted average frequency values of this segment. We then visualize spectral power and weighted average frequencies across multiple fill segments, and finally we test for a difference between the initial and final segments for changes in SP and WAF values. To illustrate, I've shown an example of raw pressure plots where both vesical and abdominal pressures are visible here. We apply the FFT to obtain the amplitude spectra shown here, and from spectral subtraction we are able to detect the bladder specific power components of this particular segment, and from this we calculate spectral power and weighted average frequency of this segment, which shows that contributions of individual frequency components towards NVC signals in this segment are clearly depicted in this plot. Plotting these values against fill levels, we observe that the spectral power is increasing with bladder filling while weighted average frequency is going down with bladder filling. So these two quantities are showing opposing trends with respect to bladder fill levels. Applying the t-test to the initial versus final fill segments for both quantities, we see that both SP and WAF show statistically significant variations between initial and final fill segments while preserving their respective trends of increase and decrease with fill levels. To summarize our findings, we see that spectral power is increasing significantly with bladder filling, while the weighted average frequency reduces with bladder filling, and both components or both quantities are showing statistically significant variations between initial and final fill segments. To conclude, we have established a workflow that can detect and quantify non-voiding contraction signals from retrospective clinical urodynamics data, and spectral power and weighted average frequency appear to convey useful information about non-voiding contraction signal changes that occur as a consequence of bladder filling. Both spectral power and weighted average frequency have shown statistically significant variations as a result of bladder filling that indicate strong changes in bladder pressure dynamics and our ability to capture these changes using our workflow. For future directions, we hope to understand the clinical significance of our results by comparing NVC signals in DO and non-DO groups. We also want to test the effects of therapies on NVC signals. We are examining the effects of larger urge contractions on their contributions towards initial versus final fill differences. We are considering extending our range of interest to beyond 1 to 10 cycles per minute. We are also testing other methods like wavelet transforms on quantification of these NVC signals, and in the long term we are hoping to develop large animal urodynamics models and even extend our workflow towards human prospective clinical urodynamic studies. Thank you.